assembly, so basically this is the basic setting for diffuser. So you inject here the air. It could be normal compressed air. It could be ozone. It could be hydrogen, whatever gas you want to infuse into water. Yes. Here it is the water inlet. It will go here and flush the bubble that form at the surface of the ceramic head. The ceramic head is really something. This moves like a glass. You know, when you touch it, it's really like a glass. But they are very tiny hole. It's a porous material actually. They managed to make a very porous material. And the big advantage of this diffuser compared to other nanobubble technology, it's what we call the pressure drop. It needs very low pressure to create the bubble. That's where it is the saving in this technology, because most of other technology, they are injecting, or they are using cavitation, using lots of mechanical stuff to produce the bubble. But here you just inject a little bit air here. And I can send you some video I made at home also with a small fish pond with this device.
Please, yeah.
And then this is the outlet, and the outlet will be water and nanobubbles. And the nanobubbles are so small that when it go out from this outlet, you will see a kind of fog.
Wow.
And the fog is composed of nanobubbles, and most of the bubbles stay in the water. And you will
have
the water
very
blur.
For several days?
For many times, I cannot measure because you should have some equipment. But actually, the phenomena of nanobubble is working like that. Once the bubble come here, you can see them. But in a certain time, they collapse, disappear. They just infuse directly in the water, and they don't come up at the surface then. That's the big advantage of the nanobubbles. They don't come up at the surface. Anything that it dissolve, basically dissolve directly into the water. So if you want to be very efficient, instead of injecting air here, because air contains only 21% of oxygen.
Oxygen, yes.
So you can use a separator upstream that separate the nitrogen from the air, and you inject pure oxygen here. So the time you will infuse and inject oxygen in the water will be 5 times less, because you have 5 times more oxygen in the same volume than in normal air. So this is the way that you can save a lot of money, because you save on electricity. If you save on electricity, as Vietnam is 70% fossil fuel, you can deduct the carbon reduction in that way.
Yes. Is there any research on that? Any data that we can use to do validation for greenhouse mechanism?
I think Hiroshi has some.
Yeah.
Because Hiroshi is only I would say the partner is not the owner of the patent. The owner of the patent is Ansai, and I think he has some data about this. And he's one of the rare suppliers who made the measurement of the performance. It means that if you want to measure the nanobubble in water, you need a very expensive equipment that use laser, that count the bubble. Because you need to count the bubble, and you need to also measure the size of the nanobubble.
Yeah.
And his device is producing the smallest size and the highest number of nanobubbles. So he has his type of reports already. So applied to water treatment. Water treatment, basically, you have different stages in water treatment. I'm working also now in that field and providing solutions from Denmark for sludge dewatering. So water treatment, I know a little bit about that. So in a certain stage of the water treatment, we are using aerators. Basically, you inject air with the blower into the tank, and you make bubbles.
Yes.
So it has 2 purposes. The first purpose is to mix the tank.
Yes.
And the second one is to bring the oxygen for the microbes to digest the sludge.
Yes.
To digest the organic matter.
Yeah.
The problem is that all these bubbles are coming up at the surface.
Yeah.
So there is little oxygen that stay in the water. So you need a lot of energy. It's basically the first consumer, electric consumer in a wastewater treatment plant is the blower. Is because you need lots of air to inject into the aerobic tank, and that's the saving that you can do. He has already some data regarding that, and basically you just add this system into the existing one. So you inject the water or the oxygen, but you reduce the operating time of the blower.
Yes,
So you
yes.
have a kind of sequence, and you can reduce, and they can save at least, I think last time he told me, 20% on the power consumption.
I see.
So alone, only the air aeration part, you can reduce half of the power consumption. And in terms of carbon, depending of the energy mix of the place where you are, you can estimate how much carbon you have saved by the energy saving.
I see. I
So
see.
that's simpler as that. So you can use it in any field that need to inject a gas in water, and specifically in this pandemic time, you can use ozone in order to make disinfection. So you inject the air. I can show you what
Yes, please. Yeah, please. Yeah. With the
an
ozone. Yes.
ozone device looks like.
Yes. Yes.
So this is a small ozone device. This is very simple.
Uh-huh.
I bought it in Vietnam, so it cost something like 700,000.
Oh wow.
Yeah, very,
It's
very cheap.
like $30. Yeah.
Yeah. Actually, cheaper because I bought with the casing. But if you buy only the electronics inside, so it's basically high voltage plates, it costs half the price. So
Wow.
because you have the handle, a stainless steel casing, and all this, it's a little bit more expensive. So you just plug it, and here you have a fan, and
Yes.
it blows the air here. It passes through the place, the high voltage place here, and it generates ozone from there, from that side.
I see.
From that, you compress it through a compressor, and then from that, you flush. The compressor will send
see.
the air, the ozone here, and the water will be flushed with a pump
see.
and flush it. So this is basically how it works. You can use hydrogen, you can use any kind of gas, and you have many applications here in Vietnam. I read your report regarding the assessment of the carbon saving. You can do, if you're doing this on a shrimp farm or a fishery, there are lots of, I would say, carbon saving, because the fishes and the shrimp that are grown in Vietnam, they are using a lot of chemicals.
Yes.
And
So
chemicals,
I was talking. I was just talking to the VOAA. Do you know them? Organic Organization.
The association, yeah.
Yes, I just finished talking to them. I think they'd be very interested in this technology because, especially for organics, if we need to prove how it can reduce, improve the organic certification of products if we use this technology. Actually, they're in Hanoi, and I'm planning to meet with them next week. So they'd be very interested in applications with regards to organic farming.
Yeah.
Do you know what the link is? What is the link? What is the link between organic farming and this technology? Is there anything?
Yeah, very easy, very easy. The first is exactly the one that I explained to you for wastewater, because we inject. You have the paddle aerator in the shrimp farm. The wheel that are turning. This is for aeration purpose, and this is highly inefficient. Because it uses a mechanical system, and it uses lots of energy just to make some splash above the water. And it brings very few oxygen into the water.
Yes.
So with this equipment, you can aerate much better because you infuse directly the oxygen into the fish tank or the shrimp tank, and then you don't need much power. This is the first is power saving. The second one is the reduced need, or maybe you don't need it anymore, any chemicals. Basically, the chemicals they are using is antibiotics.
Yes.
And the problem is it kills everything. It kills the microbiota of the shrimp and the fishes. And they need to put more and more because the bacteria become resistant to the antibiotics, and you end up with seafood or fish that is full of antibiotics. Mm-hmm. So that's why, when I went back to France for holiday, for summer holiday, when I go to the supermarket, I saw the Vietnamese shrimp farm. They are sold at €7 1 kilo. This is the lowest price we can find in France. Is the shrimp from Vietnam. Mm. When I go to check the shrimp from Madagascar, which is the number one in the world because it's organic, it's $35 a kilo. So you can focus on quality, but you need to invest before. And as I told you by email, the problem is Vietnamese are always wanting to save on the capex. Yes. They don't care about the efficiency after. So it's very difficult to convince them to invest more than they could do with very low quality Chinese product. So we need, I got more feedback when the companies are foreign owned, and especially when they are MNC, so they have also subsidiary in different parts of the world, so they can better understand the advantage of investing more upfront rather than saving more. Because if you want to save more upfront, you cannot access to high technology. You will access to the lowest copied technology from China. Yes, and that's why the Vietnam has some difficulty to reach that market, the organic market, because it needs some effort, it needs some money upfront. So when you save on the medicine and antibiotics products, you can calculate what is the cost impact of such antibiotic or such medicine that you are using.
Right? Are you saying that you could eliminate all antibiotics?
Normally you can eliminate, because Hiroshi told me that he has some experience with a shrimp farm in Malaysia, and he told me that they don't use a single chemical.
Wow.
It means that the whole set of chemicals that they are using, you can calculate the carbon impact of producing these chemicals, and you say, yes, this is the saving.
Yes.
And it's very easy to demonstrate, because you just make the analysis of the shrimp, and you can detect right away if they contain antibiotics or not, or the water, simply the water of the pond. You make a sample, and you will know directly how much pollution you have inside. Lots of people claim that they are organic, but they are not actually.
Yes, yes.
They just hide the product behind. But when you make a sample that talks, so it's very easy to check that. And if they spend a lot of money to get the certification, they can lose it very quickly.
Yes, yes.
So the saving is on the aeration and on the chemical used for growing this shrimp. They will have also a better yield, so they produce more,
yes,
healthier product, and they can sell it at a higher price.
I see.
So this is very easy to understand, because when I saw the link that you sent me regarding the cow feed, they are also counting in the same way.
Sorry, the what?
The cow feed, the animal feed.
Oh yes.
Yeah.
Yes.
So you feed the cow with something that increase their yield, their size. So you can reduce the time from D0 to slaughtering.
Yes.
So this time
Save
you
time,
save
save
also.
money. Yeah, save
So
money.
you can apply the same. You can apply basically the same calculation that was done from the cow for the shrimp.
Yes, and fish.
So other fishes or whatever animal you grow, if you can manage to increase the growth
Yeah.
without using any chemicals, the calculation is the same. The product will not be the same. The impact of each product will not be the same, but the way of calculating is exactly the same. So that's the advantage of the nanobubble. You save on electricity and on the chemicals and medicine that you use normally in the feed that you put in the animals.
Yeah. What about
That's
hydroponics?
basically the
Yes,
difference.
there are hydroponics that combine with aquaculture. Have you seen that? Where they
Yeah, yeah,
combine
yeah,
in
yeah, yeah.
Vietnam,
Of course.
they have some projects like that where they combine hydroponics with aquaculture.
Yeah, this is called yeah, yeah. This is what I done. I did at home. I have also a small aquaponics system that I don't know if you can see here outside.
Uh-huh.
Here, this is a small aquaponic system outside.
Uh-huh.
Let me check.
Okay.
I just turned the video, but yes. Here, you see?
Yes. Yes.
So this is
Yes.
the plant above and the fishes. I don't have fishes anymore, but this is the fish tank, and above you have
The plants. Yes.
the plants. So you can use it. You can use it for aquaponics, but you should be very careful because Hiroshi has also use it, sell it to a farm, and the dosage of oxygen shall be very well monitored, because the problem, if you inject too much oxygen into the water, it burns the roots and the plants doesn't grow enough. It's a balance to find. It's so efficient that you provide too much oxygen. I noticed the same in my aquaponics. I put it all the time and I saw that the plant didn't grow faster.
But don't plants need CO2?
No, they need CO2 for the leaves, but
Oh,
you need some oxygen into the water, because
Yes.
life in water comes from oxygen. If you don't have oxygen, you create algae, you create anaerobic condition, and it doesn't grow that much. So it works also for the dead water bodies. If you have a lake that has lots of algae, and this algae, is killing all the fishes, so you can inject the nanobubbles using oxygen and ozone at the same time. Ozone will kill the algae, and oxygen will promote the life after. I don't know if he sent you the one used in the US. There's a company using this technology, and they brought back to life a lake.
Yes.
Especially in summer when the lake, when the weather is very hot, and there are too much fishes into the lake. In the lake, they need to treat it with oxygen in order to bring back the life. So they managed to do it in a few days. And this is also saving lots of CO2, because any fishes that is dying is also producing CO2, by
And the breakdown.
the biogas. Yeah.
Yes. Yeah.
And anywhere you can estimate the carbon on that way, based on what you are really saving in terms of CO2 if you didn't do that, or if you use another technology which is less efficient. Because nanobubbles, you have probably, it's like in wave energy, you have probably a dozen type of technology. The most simple one is just to inject the oxygen in the water tank. The other ones have swirling device. Other one use ultrasonic or microwave to generate the bubbles. But at the end, what is important is the scalability of the technology.
Yes, exactly.
If you need to have you heard about the Tolik River in Hanoi?
Yes.
when they use nanobubble. This is a cheaty technology. Actually, the guy is not what his claim about the technology. He say he was the UN advisor or whatever. It was all bullshit, and they were using a kind of uh, swirling fan, which is with water injection, and this is one of the most power consuming device, because each time you have a moving part, a mechanical part which is moving, you are producing a lot. You need lots of energy actually. But here you don't have any moving part. You have just the water that needs to be
Yes.
injected here and the air here. There's no moving part inside like
Yes.
other technology. That's why it's more cost efficient to use this type of technology. And after, in order to prove, you need to measure how much oxygen you inject into the water compared to the power consumption of your compressor and your water pump.
Could you get well? Oxygen is expensive. Could you get benefits with just pumping air?
Yes, of course. It's just a trade-off to make based on the result you want. For sure, oxygen is diluting much easier than air, because air you have the biggest part is
It's
nitrogen.
nitrogen, yes.
So
Yeah.
it's the oxygen dissolve better into the water. So you will lose less operation time by using oxygen. So you
What
need to.
about what about ozone into the water? Are
Yes,
they?
ozone water works well. Also, you need to control it, because ozone is a very is a highly oxidant gas. So you can use it for sanitation. It's much better than the bleach,
Yes.
because
Yes.
bleach contain chlorine,
Yes.
but ozone is only O3.
Oh,
So
yes.
when it
Breaks down. It's
degrades into
O2.
O2.
Yeah.
Yeah,
Yes.
and you have a better disinfectant than that, which is called hydroxyl or radical OH, and it is more efficient than ozone.
That's
It's
peroxide,
basically.
right? Isn't that peroxide? That's peroxide. Hydrogen peroxide.
No. It's the hydrogen peroxide is we call it
HOH.
H2O3 or H2O2.
Yes.
This is for making white,
Yeah. Yes.
for
Yeah.
removing the
Peroxide.
color.
Yes. Yes.
Yeah.
Peroxide.
This
That's
is hydrogen peroxide. This is not hydrogen peroxide. Hydroxyl. You check for radical OH
yes.
or
OH.
hydroxyl
Yes. Yes. I
or
know. I understand.
hydroxyl. So this is
Yes.
a different. You produce it by using UV lamps, UV
Yes.
light on the ozone.
Okay. Got it.
So when you use it, you break down a bond and you create some oxygen ion that is oxidating much more than ozone.
I
So
see.
the big advantage of that, it disappears very quickly. So you apply it and it doesn't stay. You don't have the smell like ozone. Ozone has a very strong smell.
Yes.
And
Yes.
it's not good to smell it. But once it is in the water, it can be used as a very good disinfectant, a natural one for seafood. And I think Hiroshi sent you also. They use it for oyster packaging
Yes.
in Japan, and they use it to disinfect the oyster before packaging, and then they don't need any chemicals. So again, you can compare the impact of using bleach or other disinfectant compared to ozonate water.
I see.
And that's the way.
Okay.
So you can use air for sure, but you need to calculate, depending of the application, what is the efficiency that is reached in a certain time. If
Yeah.
let's say you need to operate it 10 times more than oxygen, so it's better to use oxygen.
I see.
The factor is 5 actually. The factor
Yeah.
is 5 because you have you have one fifth of oxygen in the air. So
Yeah. Well, I want to think, if it's a large project, you need a large amount of oxygen, so you might not have the best return on the investment. That's only my suggestion on using air for maybe a large project.
Oh, okay,
Yes,
okay. Very easy. Normally, I was working in oil and gas, so everything related to gas
yes.
is quite straightforward. Uh, if you want to use at a very small scale, let's say, you use just a bottle of oxygen that you buy on the
Yeah,
market,
yes.
or medical oxygen. If you want to go at a higher scale, you use an on-site separation unit.
Okay,
We
got
call
it.
it a PSA. If you are at a higher scale, you use liquid oxygen, and you
Okay.
get delivered the liquid oxygen from Air Liquide or Linde or whatever
Yes, yes, yeah.
supplier. So it's really an assessment of the cost, and of course of the credit carbon that come to deduct the cost, and the size of the plant. I cannot say that it is better here and there. It depends of the efficiency you are looking for. So it could be using only air. If you don't need, if you want to save on capex, you just use compressed air. But if you want to have something more efficient, it's better to use oxygen, because to produce oxygen, you need anyway you need energy,
Yeah,
because you
yes,
need to compress the air, go to the
yes.
separation
That's what I
unit,
was
and
thinking. Yes, yes,
yeah, yeah.
yes.
So it may be the same. So if it is the same in terms of impact, it's better to use only air, because you don't have this step upstream to
Yes.
separate the oxygen from the nitrogen.
Yes, I understand. So, Duke, well, I am going to meet with VOAA next week, and suggest to me how you and I can collaborate, because I find this very exciting, and I think there's an area that we could do a joint credit mechanism,
Yeah.
since
Okay.
it's Japanese technology. I think we could follow up with a meeting with my contact in Japan, who specializes in joint credit mechanism. He's Japanese and he's based in Japan. We could set up a meeting with them. But maybe you and I can work together on a MOU, NDA, and we could look at areas of collaboration.
Yeah.
Um,
Yeah. Sure.
you could maybe suggest how we can work it out. But I'm very interested in working with you.
Yeah. I have no. I think from Hiroshi side, there is nothing confidential in what we are spreading. This is really literature that you can check by yourself. So I have no basically MOU to send to you.
No, I could do an MOU, just
Yeah,
just a
if you
general
have an
MOU.
MOU,
I
if
could
you
do
have a
that.
general,
I
okay,
will. I will do.
it's not a problem. But for this type of project, you need a project developer, right? You need
Yes.
some company that have to be established first, and then all your joint your mechanism will be tied to this project. So it will
Yes.
be a step-by-step project,
Well,
and
my company is Vietnamese, and
yeah,
it involves a project development. So
yeah.
we can do everything with my company, and collaborate. I'm just looking for ways that to finance this, and also to incorporate this in a large scale.
Ah,
Yes.
what is the type of product? Is farming, shrimp farming, or fish farming, or what are
Yeah,
you looking?
all those areas. Also, drip irrigation. So
Okay,
yeah,
the variation is even easier, because the system will be just located at the water tank,
that's right.
and
Yes.
yeah. So this is quite straightforward. And Hiroshi has already a demo plan, which is a demo system, which is here in Saigon. It's not the small stuff. It's a bigger one that is able to treat a surface of pound of about 1,000 cubic meter. So if you want to do that, you need for sure to have is all by a company, could be your company, and then from that point, making a kind of demonstration into a specific area, and of course find some investor at the first stage to finance this demonstration, because you need to invite also a third party in order to make the measurement and all this. It could not be us,
Yeah.
It could not be the farmer. It should be someone outside that come and make the measurement on the plants, on the soil, on every parameters that can prove that it brings something to the farm,
Yes.
and it can save CO2, because if the plant grow faster, you save more in terms of CO2 because you don't need to water it more, and you use less resources to grow the same plants in a shorter time.
Yes, and
So
also like in fertigation, fertigation where you have drip irrigation and combine it with natural fertilizers.
yeah,
Yes.
yeah. So basically, yeah.
BOAA might look at that because they're very much in line with the government on working on organics. They're investing more, and the Vietnamese government is much more interested with the organics market, especially now. Europe and Vietnam has a European Vietnam Free Trade Agreement, and they have to pass the ISO level for
Oh,
organics. So this is an incentive to, like you said, to get a higher price in the market for their shrimp and their even catfish. Catfish farming is a big industry in Vietnam. A lot of
yeah.
exports to the United States. So I'm sure fish farming for catfish would have a big impact.
Yeah. And also, about the certification, there
Yes.
is something to do in that field, and maybe using, the blockchain in order to get a real certification pass. I saw on your profile that you
Yeah,
are
we have
working
it.
on that.
We have
So
that.
this is very important for the traceability. If you can use the blockchain to get a real traceability, that will play a big role in order to give some, I would say, some reputation for Vietnam, because abroad is not a very good reputation.
Yes.
The product is polluted and all this,
Yes.
and then if you can prove that this product is really organic and not a boat certificate that they are currently doing,
Yes.
for sure it will open a very big market. So that's
Exactly.
the point. If you can combine your blockchain certificate
I already have.
with this, it will bring much more benefits to Vietnam than the classical stamp
Yes.
using
Yes.
organic, because it
Yes.
has basically no value.
Exactly.
Even the USDA or whatever, even the French bio, nobody believe in that.
Yes. Exactly.
They just buy it, and there is one control a year. So
Yes, I understand. Okay, I understand. Okay, Duke. I will share with you what I'm doing with the blockchain.
yeah.
We use actually anybody in the supply. If you could check, there's a company in France called Provenance. Provenance is a
Okay.
yeah. I basically do the same thing as Provenance does. We use NFC technology for traceability, and
Yeah.
anybody in the chain could use a smartphone, use NFC, and they could scan it, incorporate NFT technology, and you could trace exactly the certification steps in the supply chain.
Ah,
Yeah.
okay. I think there is a Vietnamese farmer which is doing here. They put the chip, the NFC chip on the shrimp itself,
Yes,
right?
yes, yes. They
Yeah,
could do it in the
yeah,
packaging. See, now a lot of organic farms are using QR codes. Well, QR codes can be copied on a bag. I
yeah, yeah.
could, a QR code. I just photocopy and put it on a brand and on a package. QR code is not, unless the QR code is connected to the blockchain. Yes, but a
Yeah.
QR code is. What I've seen is some fraudulent practices where a company says it's organic, they put a QR code on there, and it's organic. But I could go to a supplier for plastic bags for some crops, or and say make me 10,000 bags with the same QR code. But in the blockchain you can't do that. So I think there's a lot of applications. So let me think a little bit, and maybe I can invite you with the meeting with BOAA and also with the Japanese contact I have, who is an expert in JCMs based in Japan. because I think
Okay.
I think money is a big catalyst, and investors will push the project forward, and combined with government approval, I think this is very much needed in Vietnam.
Yeah, yeah, yeah. Yeah, exactly. Yeah. And what about also the wave energy? Are you interested in that?
Yes, I am. I need to know
Yeah,
more
yeah,
about it. Absolutely.
yeah, yeah. So next time we can talk about this because
Yes.
to me, it will be, I would say, the biggest project in my life. You know, because I was working in energy my whole career,
Yes.
and if I've managed to found this wave energy to help founding this wave energy, it will change the way energy is produced in the world.
Yes,
It will
please.
change the way, you know. So this is
Yes.
something that I'm supporting Hayes for almost 2 years now, thanks to my daughter who introduced me the inventor. But this
Where are they from?
technology is
Where
so
is it from?
simple.
Where is it from?
He's from France. He's from
From
France.
France. Okay.
Yeah, yeah. So he's living in Bordeaux, and here he invented it. But you know, he's not a guy coming from, I would say, the normal path of all the people in energy expect to have. You basically in France need to hold a degree in energy if you want to be heard by people.
It's like Vietnam.
Same in Vietnam because the Vietnam education was set up by the French. You know,
Yes, yes,
it's a very elitist,
yes,
and you have to work hard to repeat the same bullshit.
yes,
And sometimes you can introduce some mistakes in the teaching, and people don't even notice. You know,
yes, yes, yes,
and that's the problem in France. The big problem in France that you have also a kind of mafia at the top
yes,
of the
yes,
200 company that will prevent you to reach that position. And that's why
yes.
I'm here actually, because I realized when I was graduated from my engineer school, and I make, you know, the internship in big company like Thomson at that time, and I saw all this power made by this mafia of engineer school or business school. So I saw that, oh, I will not make any career in France because there is this upper stage that is reserved for this guy.
Yes.
And if you are not coming from there, people don't listen to you. And Jean-Luc Stanek, the inventor, he was a physician. He was a doctor working for the army. And then from that, he was a diver also. And he realized the force of the wave when he was diving. And he was, during 15 years, looking at how to capture efficiently the wave energy. And he understood why all other failed. And they all failed for the same reason. And all the mistakes are repeating year after year. And you see now equipment that failed before and that are still getting founded. That's just crazy. You know, they are still getting founded, but we know that it doesn't work because
I
it's a
see.
law of physics. Law of physics is very simple. Huh? You just need, you have some forces that go here and there, and
Yes.
how to transform it into electric power. And electric power here right now, you
It's
have
all coal. Yeah.
you have to spin rotating equipment. Basically, if you are using nuclear, coal, or whatever energy right now, which is produced, they are using something to produce heat and to spin a turbine, a steam turbine, a gas turbine, or whatever. You create a movement from the heat. And it's very basic. I would say it didn't change for a few centuries. So the problem is that how do you produce this heat and how do you produce this movement? And in wave energy, people produce this movement from the mechanical movement of the wave, which is
Yes.
up, down,
Yes.
or in any direction, and they capture it mechanically. And that's the
Yes.
mistake. The mistake when you capture something mechanically, you are subject to failure. You are subject to wear and tear.
Yes.
And because the wave are so strong,
Yes.
whatever reinforcement that you're making, it will fail. This
It
is
will
called
fail. Yes.
mechanical fatigue.
Yes.
And this technology is using a very simple principle that is called oscillating water columns. So basically, you use the wave as pneumatic piston.
Okay, I see.
So you use a container, you make chambers, which
Yes.
is what we call the columns, and when the waves come up, it will push the air into the column, and at the top of the column you have a check valve
Oh,
that
got
let
it.
the air go into one direction. That's the
I
trick.
I
The
see.
trick is the column, is the compression chamber that is after the column, because all the oscillating water column doesn't have the chamber. So there is a fluctuation like that in the air, and the turbine start to spin, stop to spin, and you cannot produce efficient energy. But when you have this compression chamber on the top, so you will store energy,
Uh-huh.
and then you will spin the turbine at the same speed all the time.
Oh, a
And the
constant speed,
trick,
yeah.
yeah, constant speed. So
So
you
you
don't
could,
need any regulator downstream for the alternator to pick up the fluctuation and anything. And he invented also a new type of turbine that can start spinning with only 3 millibars. It
wow.
means that you have 10 centimeters of
Wow.
wave, you start producing electricity.
Wow.
That's the problem with all the wave energy converter. They are very heavy because they capture the wave mechanically. So when you have a system that is heavy, that using a float or arm or whatever to create this movement and compress the hydraulic piston, you cannot capture the small wave. And the small wave are here all over the year, and they can
Yes.
capture only wave of 1 meter and above. So this system is working only 10% of the time. That's what we call the capacity factor. This is in energy. This is very important to know what is the capacity factor. Capacity factor is the real capacity that it's produced based on the real capacity. If you take a solar panel has the lowest capacity factor in all the renewable energy that we have.
Wow. Wow.
It is 10%. In Vietnam, it may be 8%. It means
Wow.
that you have 10 megawatt, you really get 8% of 10 megawatt.
Wow.
Solar wind is 30%. Wind onshore is 26% onshore and 40% offshore. And this wave energy is above 70% because you can capture all the waves all over the year. So the capacity factor is a word that people don't like to talk about. When you ask capacity factor to one technology, they scratch their head. They don't know how to reply, because this is the problem with solar and wind energy. They have a very low capacity factor, and any plant that you create, you need a fossil fuel behind, which is approximately between 10 to 50, 10 to 20% of the capacity in order to fill the gap.
I see.
Because when you don't have wind or sun, you need to feed the grid because you have the demand. You cannot feed more and you cannot feed less. Otherwise, your grid collapse. So that's why wind and solar are really good supporter of fossil energy because they
Yeah.
need it in order to start very quickly producing electricity when there is fluctuation.
I see. Well, Duke, one thing I learned about the JCM, Joint Credit Mechanism in Japan, I just learned recently, because I asked why in the agreements that I see on the Joint Credit Mechanism Agreement, it doesn't specifically state that the mechanism must use Japanese technology. So I asked the contact in Japan, and he said, no, you don't have to use Japanese technology. It's highly recommended that part of the mechanism they will that you can use they recommend that you use Japanese technology, but under a joint credit mechanism, we can integrate French technology.
Yeah. I know that we can, but it's the same for EFD or or the agency that are doing supporting the same. It's officially, I would say, I think you cannot, from a legal point of view, because of the trade agreement, to say that you have to use this. But in reality, when they do the assessment of the project, they will find another reason to refuse it by making the suitable points that they give to the project.
I
And they
see.
say, this is not the suitable point. I know that, French are doing the same here in Vietnam. When you have a very competitive contractor, like say Korean, bidding for a project, and they just kick them out, not on the price, because that they know that the price of Korean are much lower than the French one, but they use other characteristics in the assessment that kick them out. So it's not officially written, but if you have more chances, you can write it. And there are lots of ways to turn about. Let's say for GCM, you just open a company which will buy some license from ACE, and it's a Japanese company. It will be a Japanese and Vietnamese
Yes,
company
yes, yes.
that have some rights to use this technology, and that's it. You have Japanese technology, and you can co-develop this technology because they will hold the license for using this patent. And then all the new discovery will be under this company.
I
And
see.
then it will be Japanese, Vietnamese, and French, I would say. But it will show that it is Japanese. When someone say it's highly recommended, it means that you have to follow it, but we cannot say it officially.
Yeah, I
That's
see.
the that's all the CDM, all these are working the same way with the country of origin.
I see.
But you need to make the suitable company arrangement that show that you have this part inside,
I
and
see.
then it's okay. It will push the product. But wave energy to me is something that
Yes,
it
it
yeah
makes
that
sense. It
there's no
makes sense.
yeah
It makes sense. Okay,
cool
Duke.
yeah
Thank you very
Thomas,
much. Yeah, thank you very
thank
much for
you
this opportunity. I will follow up with you, and
yes
we'll have more meetings online. And I look forward to meeting you in person.
yes
You're doing great work. Great work.
yeah
Thank you.
yeah you too.
Okay, thank you, sir. Okay,
Yeah.
take care.
Thank you Thomas, take care too.
Okay, bye
Bye bye.
bye.